Algebra 2, Section 2.6, Families of Functions. Families of functions have certain common characteristics, and a parent function then is the simplest form of a family of functions with these characteristics. So for example, lines. Lines all have some of the same common characteristics, the shape of the graph, the fact that there's an x and a y in it. Exceptions would be horizontal and vertical lines, but those aren't going to be included in parent functions anyway. The evidence of an x and a y and there's no powers or something like that. That's all lines kind of have some of the they have a group of characteristics. Well, the parent function for a line would be just y equals x. Okay. If you were to look at quadratics, and this is something we'll study intensely in chapter 5, but maybe you know the word quadratic already. Y equals x squared would be the parent function for quadratics. We've been dealing right now with absolute value. So y equals the absolute value of x would be the simplest form of a absolute value equation that has the same common characteristics as all of the other ones in the family that would be called absolute value graphs. Okay, so that's parent function. Now let's look at an example. So describe the translation of y equals the absolute value of x minus 2 and draw its graph by translating the parent function. So they already have a graph here, so we'll just reference this. Notice that it's absolute value around the x, and then the minus 2 is outside. That's going to be critical to recognize how this behaves because of that. Okay, and the parent function would be this one right here. You can see where I'm pointing, and then the one that is the absolute value of x minus 2 would be the one that's right here. So notice what's going on with that. And actually, they're labeled. I don't know how well you can see them because everything's black, but here. This is the parent function, and it's labeling this graph. This is the translated function labeling this graph. So what's different about it? Well, it's obviously shifted down 2, and it's not a coincidence that this is minus 2. Okay, so that's basically how that works. Now, if you want to do something a little bit more extensive on this, pause the video, make a t-chart, and graph it. But we're gonna learn that that's the case with this number that's outside the absolute value. Okay, and with that in mind now, let's answer part B, which says write an equation for the translation of y equals the absolute value of x up 8 units. Again, so they're saying, so this is the parent function. If we were going to translate it up 8 units, what would the equation be? Now I'm going to say it right away, so if you want to think about that, pause the video. It would be y equals the absolute value of x plus 8. So again, this number outside the absolute value controls a vertical translation. Minus 2 meant down 2, plus 8 would be up 8 units. How about this one? Describe the translation. Describe the translation y equals the absolute value of x plus 4 and draw its graph by translating the parent function. Okay. Now let's think about that. It's not straightforward like the vertical where it's plus is up and minus is down. In fact, it's the opposite of that. I have an explanation as to why that is. I will probably give you that explanation for those people who want to know in class, because I'm trying to keep these videos shorter and it takes a little bit to explain that. So I'll probably give that explanation in class. But basically, plus 4 inside the absolute value would actually move this left. You think of right as the positive direction and left as the negative direction. Well, plus 4 actually goes in the negative direction. I'll tell you why at some point. And I'll show you the graph. There's the proof of it. And again, you could also pause the video and just take out a piece of graph paper and take a moment and graph this. But here, this again is this parent function. And then this is the translated graph. And notice that it's been translated to the left 4 units. Look at the vertex, 1, 2, 3, 4 units. Every other point that would be translated would be this right here. 1, 2, 3, 4 units is this point right here. Okay. So then with that in mind, it says write an equation for the translation of y equals the absolute value of x, the parent function, right 2 units. Pause the video if you don't want me to say it right away. That would be y equals the absolute value of x. And again, it's right 2, and it's kind of backwards from the way it was with the vertical. Right 2 is actually x minus 2. Okay, and there's a big difference between the last problem where the number, if you will, was outside the absolute outside the absolute value, whereas in here it's affecting the x directly inside the absolute value. Okay. So then, back to the notes here. We'll talk about something called a vertical stretch. A vertical stretch is narrower than the parent function. Of course, we're talking about absolute value functions right now. It's narrower. Basically, we're talking about something like this. If the parent function looks like this, okay, which means it's passing through 1, 1, 2, 2, 3, 3, 4, 4, negative 1, 1, negative 2, 2, negative 3, 3, etc. Okay, if you stretch it, and there's a certain number that we still have to talk about that causes this to happen in the equation, you're going to get something that's steeper, so to speak, or narrower, we like to say, because of the nature of this graph. That was a stretch. A shrink, vertical shrink, is wider than the parent function. So I'll do that one in green. Would be something like this. You think about it like if you took the blue one and you just squished it down, like your hands are at the top and the bottom of them, you bring them together, like you're smashing a sandwich or something. That's a shrink. Okay. So this then says describe and then draw the graph of y equals 1/4 the absolute value of x. We are going to practice one of these on my starboard, but they're providing graphs, and I think I'm doing all right to just reference what they have on the software here. Then draw the graph of y equals 1/4 x. Well, think about that. If I plug in let's say it this way. The parent function is y equals the absolute value of x. A t-chart for that would look like this. That's a y. 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. But if I take these same numbers and I plug them in here, you plug in 0, you're going to get 0. You plug in 1, 1's absolute value is 1, times 1/4 would be 1/4. You plug in 2, you're going to get 1/2. You plug in 3, you're going to get 3/4. You see how these are smaller numbers than these numbers here? By a factor of 1/4. In fact, this number, this a right here, in their little, excuse me, in their little function model there, is what affects this. And if that number is less than 1, like something between 0 and 1, it's actually going to be a shrink, okay, because these numbers are smaller. Okay, it's going to cause the graph to be wider. I'll show you. There's the graph. And again, you should be able to identify the parent function now because we've seen that a few times. And then this one here is y equals 1/4 x. You can see that's a very small label, but you should be able to see that right there. That's wider. Pardon me, I'm trying to take a drink and stop coughing. Write an equation for a vertical stretch of y equals the absolute value of x by a factor of 6. Okay, now again, pause the video if you don't want to hear right away, but this would be y equals 6 times the absolute value of x. That multiplier there, this a value, it being 6, being a number greater than 1, is going to cause it to stretch by a factor of 6. It would be much steeper. It would look like this, right? Let's see, 1, 2, 3, 4, 5, yeah, 6. And then here, 1, 2, 3, 4, 5 would be like that. It would be that steep. Sorry, I can't draw very well straight lines. Hopefully you understand. All right. Something called vertex form. This is important here. Probably this all kind of leads up to this right here. Vertex form. In vertex form, I hinted at this in the last video also, the vertex is h comma k. You can pick it right out of the equation. It's h comma k. And it also has that nature that we talked about in the earlier problems, right? Where this affects the horizontal, this affects the vertical. If you really just put those two concepts together, that's what forms the vertex. And then if you think of that latest example that we just did, that number is going to affect the vertical stretch or shrink. And one other thing, and I'm sorry to throw a whole bunch of things at you, but we will practice this one time as well, is that it will also affect whether the graph opens up or down. I say opens like it opens up like you could pour something into it and it would stay, as opposed to you putting a cup in your cupboard upside down, where anything was in the cup would drain out. That's what I think of as opening up or opening down. If it's a positive number, it opens up. If it's a negative number, it opens down. Okay. So here, for example, is a graph that is opening down. Okay. So this is going to be y equals the absolute value of x, right? There is no, the vertex is at the origin, so there's no plus or minus anything in or outside of the absolute value. But we need to figure out what number goes here, okay? And did we just establish that it's going to be negative because this is opening down? Now think about that. The parent function does this, right? It's over one, up one, over one, up one, even in the other direction too. Right one, up one, right one, up one. This was left one, up one, okay? That's the parent function. So it would stand to reason that y equals negative the absolute value of x would be the mirror of this, right? So it would go like this. And let me do that in a different color too. So this one would look like this. And I'm doing the best I can to draw straight lines here, but it's a challenge. Okay, now that's no longer the parent graph. The parent graph is still this one, but that's what this graph would look like. And now we're talking about a stretch, right? Because this is narrower. Well, what's the factor? You see that this passes through at -1 and this is at -3. That's your number. It's -3. Anything that was plugged into the parent function for x to this new graph is being multiplied by 3, -3, really, -3. All right, one last thing, and I guess this kind of puts it all together now. Graph y equals -2 times the absolute value of x minus 6 plus 3. Now, I still think that a t-chart has value here, and you could use the t-chart, but the fact that this is vertex form should give you a lot of direction, okay? Because you can pick the vertex right out. Now again, I'd like you to think about this, but I don't want to keep making the video longer. So pause the video if you want to guess or kind of investigate what the vertex is, because I'm going to tell you. And it's 6, 3, right? You can pick that right out of the equation. And yes, -6 here means that the h value is 6. +3 here means that the y value is +3. So it's 6, 3, okay? Now, then you're just going to want to pick numbers that are near 6. You see, without that, in the first method that I used, actually, I guess in the previous video, the first method that I used was to start at 0. It's not a bad way, but you could go a long ways before you actually find the vertex. Here I found it right away, and it's 6, okay? So why don't I just pick 7 and 8, 5 and 4, and see if that's going to be enough for me to go ahead and graph my graph my absolute value function. Okay, so I'm plugging 5 in. 5 minus 6 is -1. Make it take the absolute value of it. That's 1 times -2 would be -2 plus 3 is 1. 4 -2, 2 -4 plus 3 would be -1. 7 minus 6 is 1. 1 times -2 is -2 plus 3 is 1. That's not a coincidence. Oops. That's not a coincidence that is the same number. You could expect this to be -1. In fact, if you recognize a pattern here now, you would know that 3 is going to give you -3, and 9 is going to give you -3, and 10 is going to give you -5. And let's see what this looks like now. 6, 3 is here. 7, 1. 8, -1. 9, -3. This is the vertex. And you can keep going, or you can probably at this point recognize where this is going and draw yourself. About like that. Looks good. Here. Good. Okay. Okay, thanks for watching.